Good afternoon, everyone. My name is Tom. Today is our team's honor to stand here and make short presentation to all of you. As you can see in this PowerPoint, our team's project called Cytological Mapping Tool. Here is the whole project context. Next page. Our project is a web application where the user of the tool will be able to link the cytometric space and measurable numeric space, and then the tool will automatically discover the suitable mapping. This sounds a bit complicated, so let's use emotions as an example. A simple explanation is that everyone has a different backgrounds of values of emotions. For example, some people assign a value of 5 to happy, while others may have a value of 3 or 6. Not happy and very happy may also be different for different people. Our mapping tool is more like a questionnaire that collects different users' assessments of colors and emotions, and then use a special algorithm to get the most appropriate points. As we all know, abstract data such as happy and colors are usually difficult to express through data. However, in nowadays, psychometric states play an important role in assessing a person's physical and mental health. The aim of our project is visualize the abstract data in psychological space, and user maps the input abstract data to a numeric space through their chosen algorithm. The web application counts and records data in measurable numeric space, and then predict the user's psychological space values in different ranges. The tool will help create a suitable data visualization of different data. Now I hand over to my teammate, Mao. He will talk about background.
Thanks, Tom. I will talk about the background information of our project. In the daily life, people will be affected by the environment they live in. People who live in a peaceful environment are mostly happy, and people who are in trouble are often nervous. Psychometric space is an abstract concept to describe this effect. Many life events can be used as evidence. The more events are observed, the more pronounced this effect is. This effect has a strong connection to events. Then about our works, psychometric states is an important fact to mention personal mental health. In usual, abstract emotional data is difficult to express through numbers data. The target of our project is build a web application to visualize abstract data in psychometric space. This application will record the abstract data from user inputs. Then it will use algorithm to mapping this abstract data to a digital mentionable space. These algorithms include k-means, g-means, x-means, multidimensional scaling, principal concept analyzation, and so forth. With amount of statistic data, this application can build some models. This model can be used to predict the psychometric space value of current users or other users in different ranges. Let Hao Chen talk about the next part.
Hi, I'm Hao Chen, and I'm going to talk about approach and algorithm. The Agile software development is applied to our project. The team chooses Agile so we can respond to changes and feedback from customers quickly. The whole project is divided into several sprints. Each sprint we plan analysis, development, and test. At the end of the iteration, we show the client our work and get feedback from him. This minimizes overall risk. We organize group meetings via Zoom weekly. Group members report to each other what they did, their plan, and any roadblocks to the goal. The screenshot of Trello shows our work. We use Git to control our project. The code is stored in GitHub, so we can write the code together. The web project uses Spring MVC because it is fast, productive, and secure. The model encapsulates the application data. The view renders the model data. The controller processes the user requests, build models, and passes to the view. Our database uses MongoDB, which is a kind of non-circular. So you can modify the structure of data to deal with changes. It is also powerful in query and analytics. We use Docker and Jenkins to deploy our project. It helps automate the part of software development related to building, testing, and deploying, facilitating continuous integration and continuous delivery. User can map the psychometric space with 7 different algorithms. They can divide it into 3 types: clustering, multi-dimensional scaling, and projection. K-means clustering partitions and observations into K clusters, in which each observation belongs to cluster with nearest mean. G-means clustering algorithm is an extended of K-means, which try to automatically determine the number of clustering by normatic test, and X-means is based on the Bayesian information criteria scores. We get center points of each score and calculate the mean value of them. The average value is the result. Classical MDS find a set of points in the low dimensional space that will approximate the similarities. Cross-course non-metric MDS assume only the rank order of entries in the proximity matrix contains the significant information. Simon's mapping is an iterative technique for making interpoint distance in low dimensional projection, as well as possible to the interpoint distance in high dimensional object. To use MDS, we first need to calculate the non-negative proximity matrix. Principal component analysis performs a linear mapping of data to low dimensional space. Due to it is linear, we recommend not to use it. The implementation of the algorithm uses a Java library called Smile. Then Zach will talk about the result.
Thanks, Chen. Hello, I'm Zach. In this section, I will talk about the artifact results and the testing results. Our project had 4 main models. They are survey, mapping upload, projection, and questionnaire lift. Let me talk about the first function that aims to collect data from users. As shown in Figure 1, users could choose a survey that they are interested in. After that, they could click the detail button to customize their mention space by pulling the slider and enter their names, like the Figure 2. The next function is questionnaire list. In this model, administrators could view all questionnaires and create a new one. After clicking the detail button, they are able to view the data and all of the users' names. Administrators are allowed to export the data as a CSV file, and they could also choose a mapping algorithm from the list to upload the data. Please turn to the next page. Then I talk about mapping upload. Administrators could upload a CSV file and then choose the mapping algorithm that they want. The data would be displayed below like the Figure 6. The final function that we developed is projection. Administrators could view all data that from the file uploading and the questionnaire list. After clicking detail button, administrators could input a new psychometric space through entering the description and pulling the slider. Then the predicted result would be shown as the Figure 7. In terms of testing, we use GitHub Action to do CI. Once we commit a code, it would test the code automatically, and only if all the test cases are passed, the code would merge into the main branch. The Figure 8 shows the nearest junior testing results that could see the code passed all junior testing cases. Besides, the group used IKEMA Java code coverage, that is a plugin to do code coverage testing. From the Figure 9, the coverage rate is over 90%. That means the test cases have covered most of the code passes. This is all my part. Then Fu will talk about evolution and conclusion.
Thanks, Zach. My name is Fu Huang. Firstly, I will describe the evaluation of our group work. I divided the whole project into 3 main stages. which are design, develop, and deploy. We evaluate the work objectives, progress, and completions of the 3 stages to judge the quality of each stage. Let's look at this chart. We rate the quality of task in the design stage as medium. However, because we misunderstood the client's needs at the beginning of the project, our initial design was wrong. Fortunately, after our hard work, we still completed an excellent design before the end of this milestone. Secondly, the development part is rated as high quality. All function development of client requirements are completed. Some functions beyond the client expectation are also implemented in this milestone, such as CSV file export, data collection, and data prediction. Finally, the quality of deployment part is rated as low. First, compared to the plan, the process of deployment is delayed. In addition, because our deployment method is different from that required by the client, and due to the time limitation and our lack of deployment abilities and experience, we can't deploy the project with the client requirements. Therefore, the content of this part is considered as a failure. Okay, next page. In conclusion, for the completion of the project, expect that the deployment did not meet the client's requirements. The project realized all the needs that the client wanted. In addition, during the overall process of the project, the relationship between team members and tutors is harmonious. Finally, after the group discussion, we found that communication is the biggest problem in our project. At the beginning of the project, due to our lack of communication with the client, we made a wrong analysis of the client needs. In the deployment stage, the other team members did not communicate with the deployment members in time. It led to the failure of the deployment. We hope that all our team members can find their own shortcomings in this capstone project and improve themselves in the future projects. That's all of our presentation. Thank you for listening.